All right, welcome back again. So here we go. Here's where we ended last video. If you didn't watch the last video, go watch the last video. All right, so we were saying 700 was normal force. The last thing we need to do is we need to balance out the horizontal forces because it's a constant speed, so all the forces have to be zero. So what must be happening in the left direction, especially because the sled's moving to the right, is force of friction, and it must be 240. F's are really annoying to draw with this mouse. All right, so that's going to be equal to the 240 from over there. Wow. Whoa. I kind of got out of control with that 240 newtons. So sorry about that. That's a real messy free body diagram. All right, so remember that 240. We're going to go up and use that somewhere else. Oh, right here. So we are going to say that it's asking us about the coefficient of kinetic friction. And all we have to do is use force of friction is mu times normal force. Force of friction we just calculated was 240. Stop it. Just stop. And normal force was 700. And that gives us a mu when you divide 240 by 700 of 0.34. And we're done with that one. I'm going to erase. I'm just going to keep going. All right, last one. Lucy's holding this box against the wall at rest. Here we go. And we're going to draw the free body diagram. So we've got a 20 kilogram box. And what we notice, so that's FG of 200. What you probably notice is that it's on the wall. Okay, so keep in mind that we're talking about the free body diagram, and the surface is in contact with is the wall, which is a vertical surface, which means that we're going to have a horizontal normal force. So what was I doing again? 200. Well, that's a better 2 than last time. I'm telling you, these 2s are tricky. Here we go. All right, so the next thing I'm going to do, I'm going to draw what's given. I'm going to draw the component form of her force, which is 160 going to the x direction, 120 going up. The reason I didn't draw a normal force yet is because I have another vertical force. Actually, because it's not even a vertical force. So F of Lucy X is equal to 160. Come on. And we also know this box is at rest. So we know that the next step after I draw this stuff is that we're going to balance out all the forces because if it's at rest and staying at rest, wow, then we want the F net to be 0. Oh boy. See those 2s, you guys are getting me every time. Okay, so we've got 2 things left to do. We've got to do normal force, which points this way. And that's going to be equal to 160 to balance that out. Okay, and then we've got to balance out the vertical forces. So we've got 120 pointing up, 200 pointing down. So we need 80 more pointing up. And that's going to be force of friction. That's our static friction right now, which is great because that's what they're asking us for next. And actually, technically, oh, that's why it says the minimum amount. I was going to say technically we can't figure it out, but this is like the minimum. When they say that it's the minimum amount of force, that means the minimum amount of force needed to keep that box from falling down. Okay, so there's my free body diagram. Messy as, when I have to figure out the coefficient of static friction, I'm going to use force of friction is equal to mu times normal force. And I'm going to use that force of friction is 80, and that's equal to mu times 160. And our mu is 0.5. That's it, folks. Now, let's see if I can turn this off.